Hi everyone. Today we are going to look after the topic kinematic indeterminacy. So let me directly go to the topic. Okay. So what are the elements in kinematic indeterminacy? As in the earlier classes, we have said that the internal displacements are called as the kinematic indeterminacy. So elements, what are the elements? They are classified as three categories. One is horizontal displacements, vertical displacements, and moment displacements. So moment displacements are also called as the angular displacements, so which is indicated in theta, and for horizontal displacement it is indicated as y of x, and for vertical displacement it is indicated as y of y. So these are the main three main elements which we need to consider in all the cases, in case of beams or trusses or even in frames. So we need to consider only these three elements in calculating the degree of kinematic indeterminacy. Let me go to the problem. So we'll consider a beam. Since there are three classifications, we'll go for the beam. So there is a fixed, and there is a hinge, and there is a roller. So before that, I want to express you what are the resistance of all these supports. So let me take a fixed beam. So fixed beam has a resistance to the horizontal, vertical and angular. So which means the kinematic indeterminacy of that particular end is 0. In case of simply supported, it resists the horizontal and vertical. So when we compare to the equilibrium deformations, so these both will get cancelled, the value will be 1. So in case of the roller, it alone take only the vertical. So when we compare with the standard deformations, the vertical alone will get cancelled, the else will be 2. So this is for an internal hinge, So there will be two different moments and there will be two different displacements. So it can be directly taken as 4. It won't be compared with the standard deformation. It's directly taken as the 4. We need to keep this in mind. So for calculations. So we know that for a fixed beam, there are three reactions, or there are three resistance. For simply supported beam, it is a horizontal and vertical, which means 2, and for a roller it is a 1. So you just write the standard deformations above this and you just minus it. 3 minus 3 0, 3 minus 2, here it is 1, and 3 minus 1 it is 2. So you just sum out all this. So 2 plus 1, so which is equal to 3. That is the degree of kinematic indeterminacy. Hope it's useful, and this is the simplest way of calculating the degree of kinematic indeterminacy. So let me look after the second problem. So in this case, there is a hinge. You know, there is the hinge responses are 2. So we may write 2. The standard deformations are 3. And this case, you know, it's 4. So it should not be compared with the standard deformations. And for here, there is 3. So the responses is 3. And I'm writing the standard things. So 3 minus 2, it's 1. And this is 4. And 3 minus 3, it's 0. So therefore dk is equal to 1 plus 4, which is equal to 5. So this is the degree of kinematic indeterminacy for this particular beam. And for here, so it's a fixed beam. So there will be the responses of 3, and to that of standard is 3. And this is also fixed. So the responses will be 3. To that standard deformation, it's 3. So it is a fixed. So it will be 2. So 3 and 2. So this is also simply supported. Sorry, it's not fixed, it's a simple supporter. So it will be 2. So the responses will be 2. So this is 0, and this is 3 minus 2 1. This is 3 minus 2 1, and this is 3 minus 3 0. So therefore degree of kinematic indeterminacy is 1 plus 1, which is equal to 2. So let us now calculate the degree of kinematic indeterminacy for a truss. So let me take this truss. So in case of truss, only the deflection at x and deflection at y exist. Always theta will be equal to 0. That means the moment response or the moment deformation will be equals to 0. So for truss conditions, the standard equation is 2. So it's not 3. You need to keep in mind for truss condition it is 2. For beams and frames, the standard conditions or the standard deformations will be 3. So you need to keep in mind. So you see here, so it is a simply supported, it will take 2. So the response is 2 and the standard equation is also 2. So here it is 1 roller. So the response is 1, the standard is 2. So you can equate it 0 and 2 minus 1 it is 1. So for every joints in a truss there will be 2 deformations. So one is along x-axis and one is along y-axis. So there will be 2 for every joints. So you may count here for a joint it's 2. For a joint it's 2. So 2, 4, 6, 8. So overall joint is 8 and for support reaction it's 0 plus 1. So the degree of kinematic indeterminacy is 8 plus 1, 9. So that is the degree of kinematic indeterminacy. So let me take this problem. So for here also it's 1 and 2. So 2 by 2, obviously this equation is 0. So here it is 1. So 2 by 1, 2 minus 1 which is 1. So for this joint it's 2, 2, 2 and 2. So therefore degree of kinematic indeterminacy is 2, 4, 6, 8 plus 0 plus 1 which is 9. So this is how we are calculating the degree of kinematic indeterminacy for a truss. Let me now solve a problem of frame to find out the degree of kinematic indeterminacy. In case of frames, all the 3 deformations are considered, I mean y of x, y of y and theta xy. So these 3, so the standard equation value is 3. So only for truss we'll take the standard equation as 2. So and also in connections, in this connections, so in truss these are called as joints, in frames these are called as connections. In connections there will be always 3 deformations. There will be always 3 deformations. So in a connection the number of unknown deformation is 3. You just keep in mind. So let me now go to the supports. So carry of supports we have 3 since it's a fixed. So we have 3. So now we know the standard equation which is also 3 standard deformations. So which is 0, which is 0. Therefore kinematic indeterminacy is 3 plus 3, 6 plus 0. So which is 6. So the degree of kinematic indeterminacy is 6. So let me now go to this frame structure. So this is a fixed. So fixed it is 3. We know. So 3 out of 3. So it's a simply supported. So it have horizontal and a vertical resistance. So it is 2 out of 3. And it has only the vertical resistance, which means when 1 out of 3. So now we calculated 3 minus 3 as 0, 3 minus 2 as 1 and 3 minus 1 as 2. So all these joints, the connections, we have 3 as the responses or the deformations. So 3, 3, 9 plus 3, 27. So dk is 27 for connections plus 1 plus 2, 3. 3 for supports. So therefore dk is 30. So this is how we are calculating the kinematic indeterminacy for beams, trusses and frames. Thank you.